All right, so we're going to look at a couple more examples and some things from the book. So, for example, what about sum? Maybe we don't already do this one, but we'll do it anyway. Sum n equals 1 to infinity of 1/3 to the n. What do you think? Does that converge or not? And what does it converge to? So while you're thinking about that, by the way, that represents 1/3 plus 1/9 plus 1/27 plus etc. forever. Okay, so this is geometric with A1 equals 1/3 and R equals 1/3. So that means that the sum from n equals 1 to infinity of 1/3 to the n equals A sub 1, which is 1/3 over 1 minus R, which is 1/3. It's 1/3 over 2/3. It equals 1/2. There, you just added up infinitely many fractions. You think adding fractions was hard? You just added infinitely many fractions in less than a minute. Cool. All right. Here's a weird one, though. We know that these things converge for absolute value of r less than 1. So what if we had negative 1/2 to the n? So first of all, like I pulled a couple of tricks here. Like I didn't really, I guess I'd sort of analyzed what these were. Like usually, I mean, I can write out what this is, but usually don't we like to see like, a sub 1 times r to the n minus 1, and we have r to the n. We have that here too. Well, by the way, be aware that you can rewrite these things. So this is equal to negative 1/2 times negative 1/2 to the n minus 1. See, so that way I can see the a sub 1 is negative 1/2 and the r is negative 1/2. But I can also get that by just writing out a couple of terms from here. So put in n equals 1, I get negative 1/2, and then n equals 2, I get plus 1/4. And so writing it out this way sort of lets me see how sort of weird this is, because I have these fractions that are decreasing, but they're also alternating sign. So we know if I have positive 1/2 to the n, it adds up to 1. We already did that one. What if negative 1/2 to the n? What's that going to add up to? Well, since we're geometric, with absolute value of r is equal to absolute value of negative 1/2 is equal to 1/2 is less than 1. So absolute value of r is less than 1. So it should converge, and we should be able to use the formula. Sum from n equals 1 to infinity of negative 1/2 to the nth power equals our a sub 1, which is negative 1/2. I can get that here or here. Negative 1/2 over 1 minus my r. Well, I can see that I'm multiplying by negative 1/2. I can pick it from here, whatever you like. Negative 1/2. So I get negative 1/2 over, this will be 3/2. So this equals negative 1/3. So these infinitely many fractions add up to a negative. When it starts at negative 1/2, and you add a fourth, so you have negative 1/4, and then you subtract 1/8, so you have negative 3/8, and then you add a 16th, so you have negative 5/16. All right, so it keeps going back and forth, but it stays negative. Basically, if I look at a graph of S sub n, S sub n is doing this, and it's coming up to, it might jump above and below, but it's coming up to negative 1/3. That's what the partial sums are going to. So this sum is negative 1/3. Okay, what other fun things? So here's something that we really can see from this one clearly. All right, when I have this, geometric series with 1.1, so I'm going to have 1.1 and then 1.21 and then 1.331 and then excuse the Pascal's triangle, so 1.3631 or something. All right, so the values of the sequence keep increasing. So in order for the series, if I'm going to add them up, the values have to be getting smaller. Right, so if I want to do A1 plus A2 plus A3 plus A4 plus etc., all right, and I want to add up infinitely many of them, the A's have to be getting smaller, right? They can't be getting bigger, and they also can't be staying the same. Like they can't be 2, 2, 2, 2, because I'm going to be adding up infinitely many things. So what we have is essentially for the sum from n equals 1 to infinity of a sub n to converge, in other words, to have a real value and not be infinite, the limit as n approaches infinity of a sub n must be 0. So we have different ways of stating that. One is to state the contrapositive of this, which is the limit, this is probably the most common way to use it. If the limit as n approaches infinity of a sub n is not equal to 0, then the sum from n equals 1 to infinity of a sub n diverges. So this important result is fairly intuitive if you think about what these things mean. This is called the nth term test. And it basically means that if your terms of the sequence are not tending to 0, then you're not going to add up to a finite number, right? That's what this says. If the terms don't go to 0, then the sum is not going to be finite. Okay. Now, but be aware though, if the limit as n approaches infinity of a sub n is 0, that does not mean that the series converges. All right. Sum from n equals 1 to infinity in that case, if all I know is that the limit as a sub n approaches 0, that sum from n equals 1 to infinity of a sub n might converge or diverge. And it's this unknown aspect, once the limit is approaching 0, that is going to cause us boundless headaches as we go forward and cause our whole, chapter to evolve, is how do we know, once we know that the sequence is approaching 0, how do we know if the series converges or not? And there are a lot of different things for us to look at to figure that out. So I think next we're going to start looking at some problems from the book.